Okay, so 10.7 deals with complex numbers. So complex numbers are numbers written in a real number plus an imaginary number. Number term. So they call it the A plus BI form. The A is the real number part, and then the BI form is the imaginary number part. So this I is what we're learning. So I is defined as the square root of a -1. So I is defined as the square root of -1. So I is an imaginary unit. The imaginary unit. So where does the I come from? So when we have the square root of a -1, and so we want to understand that when we're squaring something, there's no way you can square something, meaning raise it to the second power, and it come out as a negative. So let's look at, for example, and we're just putting this in a little side bubble while we try to understand this square root of a -1. So if we have -2 to the second power, what is that? It's -2 times -2, which is a 4. If you have 2 to the second power, it's also 2 times 2, which is a 4. So anytime you raise a negative number to the second power, you will only get the positive outcome of it. So to square root a negative is to create or introduce an imaginary unit that is not real. Okay, and so essentially whenever you see the square root of something negative, you want to understand that the only way you can actually have it is for you to actually be looking at, so let's look at the square root of -4. Well, really what we're looking at is the square root of -1 times a 4. Because you cannot raise anything to the second power and it come out negative. So you want to separate the -1 from the value so that you can understand that you're really doing the square root of -1 times the square root of 4. And so the square root of -1 is now being defined for you as an I. And then you do the square root of 4. Well, the square root of 4 is a what? Is a 2. So your answer would be 2I. So I took it step by step by step. So let's look at the square root of -16. So what does that mean? Well, it's really -1 times 16. Well, the square root of a -1 is I. And then the square root of 16 is 4. So 4I, you write it as a regular term. The coefficient should always be leading the term. So I'm taking it multiple steps, but if you just want to do it quickly, the square root of -25, well, as soon as I see a negative under the square root, I automatically pull out the imaginary I. And so then I'm left to simplify the square root of 25, which is simply 5. So I have 5I as my answer. So the square root of -12. So the square root of -12, we're going to pull out the I for the imaginary. And then we have the square root of 12, so we break 12 down. So we're going to get 2I times the square root of 3. And that's it. So the imaginary I. Okay? So anytime you're doing the square root of a negative, you pull out the I and then you just simplify the square root accordingly. All right? Then we have operations with complex numbers. Operations with complex numbers. So operations with complex numbers, we're adding and subtracting. So adding and subtracting is just basically combining like terms. So let's look at what we have. 4 plus 3I plus 6 minus 7I. So we have imaginary ones outside the parentheses. So we can just do 4 plus 3I plus 6 minus 7I. Because we're just combining like terms. There's a plus sign clearly between these, so it's not a multiplication. So then we combine like terms, so we end up with 10 minus 4I. And that's it. Okay. So then let's look at 6 minus 5i minus 7 plus 3i. So here we have a subtraction here between them. So we would have to distribute this negative, right? Because remember, it's an imaginary -1. So let me make sure you can see that. So minus, okay. So then we get 6 minus 5i minus 7 minus 3i. So when I distribute that -1, it allows me to get rid of my parentheses, so now I can combine like terms. So 6 minus 7 is -1. -5 minus 3 is a -8i. And we would be finished the problem. So adding and subtracting. Adding, subtracting is really just combining like terms. That's it. All you're doing is combining like terms. Okay. So in addition to the adding and subtracting, you have the idea of multiplication. And multiplying is really still the same thing as anything else we've ever done, meaning it's just about distributing. But what we want to know, the rule we need to know for multiplying is the idea of I squared being equal to a -1. So in addition to the definition of I, you need the definition of I squared. I call it a rule, but it's really like a definition. I squared is equal to -1. So when we multiply, let's look at this. 3i times 4 minus 6i. So this is its multiplication. So the 3i is outside of the parentheses, so it distributes. We treat I like we would any other variable. So we would get 12i minus 18i squared. So this is not considered a simplified answer. So it is correct, but it's not simplified because I squared can simplify into a what? Into a -1. So anytime you see an I squared, your second step should always be to rewrite it as a -1. And so then -18 times -1 is plus 18. So your directions will usually tell you to write in the a plus bi form. Write the final answer. So here we would write 18 plus 12i. So that it's in the a plus bi format. So multiplying is just distributing. The only thing is now you have to put into your treasure chest the idea, the definition of I squared being equal to -1. So that you can make sure that you actually simplify your problem completely through. So let's FOIL, a double distribute here. 4 minus 2i times 6 plus 3i. So we're distributing. So we would get 24 plus 12i. Then we're going to distribute what? This -2i. So -12i minus 6i squared. So we're looking at 24. The plus 12 minus 12 create a 0. So they cancel each other out. So then we're looking at -6. And remember, what's I squared? It's -1. So now I'm looking at 24 plus 6. So we end up with 30. So I multiplied, and then I just simplified accordingly. And whatever happens, happens. So there is no imaginary component on this problem because the middle i's canceled each other out. Okay? So that's complex numbers. That's complex numbers. So you want to be able to simplify the square root of a negative, and then you want to be able to combine like terms that contain i's and also multiply when they contain i's. So you just have to make sure you have these definitions, and then you just simplify accordingly. Okay? So that's 10.7, complex numbers. All right, so we move into 11.1. which is the square root properties. The square root properties. So what we're doing is we're solving quadratic equations. Using this square root property. So we want to make sure we remember a quadratic equation, all right, something raised to the second power. So the square root property basically says if a squared is equal to b, then a is equal to plus or minus square root of b, okay? So if a squared is equal to b, then a equals plus or minus the square root of b. So this rule here, the square root property, is really utilizing the rule or the idea that the nth root of a raised to the nth power is a. So if you have a root and you raise it to its matching exponent, it just becomes whatever was underneath it. Well, it means the same thing applies. If you have some exponent n, some variable raised to an exponent n, you can bring in its matching root and get it back, right? So an nth root can cancel out an exponent n, and an exponent n can cancel out an nth root. So here, if we're trying to get a to solve for a, and it's raised to the second power, we can simply bring in the square root of both sides of the equation, and that will allow us to solve for a. So we're basically just trying to isolate some variable that is being squared, and by getting rid of the exponent 2, we are able to do what we need to do to solve the problem. So let's look at a problem here. So let's say we have x squared is equal to 16. So what are we doing here? We're saying that x squared, some x raised to the second power, equals 16. So the square root property says that you make sure that the squared expression is isolated. So your squared expression should be isolated on one side of your equation, or one side of the equal sign. So x squared is isolated. Then you should take the square root of both sides. So now I'm going to bring in the square root of both sides. Now when you bring in the square root, you have to remember the rule and bring in the plus or minus. So x is equal to plus or minus positive 4. Okay? So then you solve once you take the square root of both sides. So my x is isolated, which means it's solved, so I'm finished. So x could be 4 or x could be negative 4. And so you want to make sure that that makes sense to you. If you raise 4 to the second power, you would get 16. Remember the original problem, x squared equals 16. We're trying to find out what is x, meaning what? What number can x be that can be squared, raised to the second power, and give you a 16? Well, 4 can be raised to the second power and give 16, but also negative 4 could be raised to the second power and give 16. So that is why you have to do plus or minus on the square root property, because the positive or negative value of that x could create that same solution, because squaring a positive or negative value will give you the same outcome. Right? So let's look at this. X squared equals 50. So what are we doing here? Well, the squared term is isolated expression. I just square both sides, raise both sides to the square root. So we get x equals plus or minus square root 50. So now I'm going to just break down 50. 25 times 2, 5 times 5. So we get x equals plus or minus 5 square root 2. So you have to make sure that you know how to break down your radicals, right? So you have to be able to break down your radicals in order to use your square root property so you can simplify accordingly. Because plus or minus square root of 50 would not be considered a simplified answer. All right, let's look at this. X plus 1 squared equals 12. So we want to solve using the square root property. So yeah, we could write this twice and FOIL it out and do all that. But because the directions are going to say to solve using the square root property, that's how you need to solve it. So it's square root property, so that's how you're going to solve it, which means bring in the square root of both sides. So the squared expression is isolated, so I bring in the square root. So automatically, it just comes out as x plus 1, and I get plus or minus square root of 12. So now I'm going to break down my square root of 12. 4 times 3, 2 times 2. So x plus 1 equals plus or minus 2 square root 3. So the plus or minus must always stay in front of the radical term. So when that 2 comes out, the plus or minus must be in front of that coefficient. So now it's not solved, right? Once we take the square root of both sides, so I took the square root of both sides, the left side just created x plus 1, the right side created plus or minus 2 square root of 3. Now I'm trying to solve. Solve meaning what? Isolate x here. So to get x by itself, I would subtract 1 from both sides. So I have negative 1 plus or minus 2 square root 3. Realize that 1 and square root of 3, these are not like terms, right? So what did we do in the chapter 10? We learned about adding and subtracting radical expressions. You can only combine if they both had a square root of 3. So realize the negative 1 is not a like term with the 2 square root of 3. So this is the final answer. So negative 1 plus 2 square root 3. Negative 1 minus 2 square root 3. There is a plus or minus button on the system, or you can write them separately. Either answer is correct. Either answer is correct. Okay. All right, let's look at another problem. So let's say if we had 3z squared minus 30 equals 0. So 3z squared minus 30 equals 0. So we could solve this using our rules from the previous chapter, or we can square root property following directions. So you have to make sure you follow directions. Solve using square root property. So the first thing is to make sure the squared expression is isolated. Well, what is the squared expression? Well, the only thing that's being raised to the second power is the z. So that means the z needs to be isolated on this side. So what would move? The 30 would move and the 3 would move. Well, who would we move first? We would move the 30 first. So we add it to itself. And we cross the equal sign. So we get 3z squared equals 30. Now what? Well, the 3 needs to move. So we would divide both sides by 3 because this is times. So z squared equals 10. Now our squared expression is isolated, so we do what? We take the square root of both sides. So z squared equals 10. I bring in the square root of both sides. So z equals plus or minus the square root of 10. The square root of 10 cannot break down. We would be finished with this problem. Okay? So the square root property, you're just bringing in the square root to get rid of whatever the squared expression is, and then you'll be able to solve by isolating your variable. Okay? All right, and then let's look at x squared equals negative 16. So if we have x squared equals negative 16, the squared expression is isolated. So we just what? Bring in the square root of both sides. So on the left side, we would have x equals to plus or minus what? What is the square root of negative 16? Well, it would be 4i. Right? So we want to make sure we remember the square root of a negative is going to leave us with an I. All right, let's look at this one. 3p squared plus 36 equals 0. So 3p squared plus 36 equals 0. So first thing is we're trying to get the p squared isolated because that's the squared expression. So we would minus 36 on both sides. So 3p squared equals negative 36. Divide both sides by 3. So p squared equals negative 12. So now we would do what? Square root both sides. So p equals plus or minus. So I pulled out the I for that negative. And now I have the I square root of 12. Well, 12 can break down, right? So when I break down 12, I have a 2 comes out and a 3 that stays in. So we get plus or minus 2i square root of 3. So that's using the square root property to solve. And let's just do one more. Y minus 3 squared is equal to 4. And honestly, I would just go back and maybe try to work some of these over on your own. Like just pause it and just see if you can get the answer. So y minus 3 squared equals 4. So the squared expression is isolated here because what is the base here? Y minus 3, right? What is being squared? So now we can square root both sides. So we get y minus 3 equals plus or minus 2. Because the square root of 4 is a 2. And I bring my plus or minus. So y minus 3 equals plus or minus 2. I'm trying to get y by itself. So when we plus 3 on both sides, what do we get? We get y equals 3 plus or minus 2, right? So these 3 and 2 are like terms. So we're going to have two separate answers. 3 plus 2, y equals 3 minus 2. So we get y equals 5, and we get y equals 1. So realize that the plus or minus is always creating two possible answers. Positive 4i, negative 4i, right? Positive 2i square root 3, negative 2i square root 3. So here, because we can combine the 3 and the 2 to actually simplify more, we have to do that. So we get a 5 and a 1. Okay? So that's square root property. That's square root property, 11.1. All right, so the last section of the course, 11.2, solving quadratic equations using the quadratic formula. So quadratic equations are of the form ax squared plus bx plus c equals 0 for this section. The quadratic formula is x equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So the quadratic formula will be provided to you on your exam, but I always recommend that you learn it, but it will be provided to you. So what we're doing here is we solved quadratic equations by factoring. That's what we learned how to do in chapter 6. We learned how to solve by factoring. So what we want to do here is we want to look at this equation that we have, 2x squared minus 4x minus 3 equals 0. So our directions are going to tell us to solve using the quadratic formula. Solve using the quadratic formula. And so that's what you do. You just solve using the quadratic formula. You make sure your equation is in the equal to 0, right? So the equation must equal 0. Then you just identify your A, B, and C. And you substitute them into your formula. And you simplify. So the quadratic formula is a formula where the x is already all isolated or solved. So you're just substituting in the a. So here it's in the equals 0, ax squared minus 4x minus 3 equals 0 form. So you want to make sure that it's in the format of ax squared plus bx plus c equals 0, right? Remember descending order. So my a is 2, my b is negative 4, my c is negative 3. So identify your a, b, c. Those are your coefficients. And then you're just going to substitute them into your formula. X equals. So I'm just directly substituting into the formula. Over 2 times 2. So negative b, so negative of negative 4 plus or minus parentheses negative 4 squared minus 4 times a 2 times c negative 3 all over 2 times 2. Then we just simplify. So 4 times 2 times 3 gives us a plus 24 over 4. And then you should just go through and simplify. So we get the square root of 40 over 4. So you break down your 40. You got to simplify. So we get 2 times 2 times 10. So 2 square root of 10 over 4. So when you look at this answer here, you look at your coefficients. You look at the 4, you look at the 2, and you look at the 4. Please understand the square root of 10 Cannot simplify with these values. The square root of 10 is a square root 10. It's not a real 10. So the 4, 2, and the 4 all have common factors of a what? They all have a 2 in common. So we're going to reduce this. So 2 plus or minus 1 square root of 10 over 2. And that would be your final answer. And remember, that's the same as what? 2 plus square root of 10 over 2. 2 minus square root of 10 over 2. So plus or minus is the same as separating the answers out. So you're just going to identify your ABC, substitute them into your formula. All of your work is simplifying. All of your work is simplifying. You should always deal with your square root part first. Always simplify that first as much as possible. Always simplify your square root as much as possible. And then finish your problem. Okay? All right, let's look at another one. Give me a second. All right, here we go. 3x squared minus 5x equals 2. So 3x squared minus 5x is equal to 2. So before we can start, we see that this is not equal to 0. So this 2 needs to move to the other side, right? So it would subtract. So we would have 3x squared minus 5x minus 2 equals 0. Now we identify A, B, and C. So my A is 3, my B is -5, my C is -2. Make sure you watch your sign. So then my formula, -b plus or minus b squared. If you write the formula every time you do a problem on your homework, you'll know the formula by the time you finish. So I'm directly substitution. 5 squared minus 4 times A times C all over 2A. And then you just start simplifying. So 25 plus 24 over 6. So 5 plus or minus the square root of 49 over 6. So the square root of 49 is what? 7. So we're looking at 5 plus or minus 7 over 6. When you look at your numerators, look at this. 5 and 7, they are what? Like terms. So what are we going to do? We're going to write this twice. So we got two possibilities. 5 plus 7 over 6, 5 minus 7 over 6. So 12 over 6 gives us a 2. -2 over 6 gives us a -1/3. So our final answers here are x is equal to 2 and -1/3. So what we do is we use the quadratic formula to be able to solve quadratic equations, because sometimes a quadratic equation doesn't factor. And so when we try to solve by factoring, it's very limited in our ability to solve certain types of polynomials that are quadratic, because every polynomial that's quadratic isn't factorable. But you still should be able to solve. And so the quadratic formula allows us to solve whether it's factorable or not. Okay? All right, let's look at another one. All right, let's see. All right, let's try this. X squared plus 5x equals -2. So x squared plus 5x equals -2. So we want to set this equal to 0. And then we want to identify our A, B, and C. So look at this one. What is this A here? This A would be 1. Remember A, B, C, coefficients. B is 5, C is 2. So remember, 1 is understood. The whole point of the quadratic formula is the x is already solved. So your A, B, and C should always be numbers. It should never be a variable as your A, B, or C. You should always be able to substitute in a number. So then we substitute. Let's write our formula. So -5 plus or minus 5 squared minus 4 times 1 times 2 all over 2 times 1. So we have -5 plus or minus 25 plus 8 over 2, negative 5 plus or minus square root of 33 over 2. So when we break down 33, we get 3 times 11. So it doesn't simplify. So this problem is finished. Nobody can reduce. So the problem is done. Oh, wait. This should be a minus 8. Sorry. Hold on. 25 minus 8. 17. So my signs were wrong here. So then 17 is prime itself, so it still doesn't simplify anymore. Okay. So that would be it. So it's just being able to solve, put it in a form where it equals 0, and then identify your A, your B, and your C. All right. So then let's do one more. X squared plus 2x. Let's try this one. X squared plus 6x plus 13. So A is 1, B is 6, C is 13. So x equals negative 6 plus or minus 6 squared minus 4 times A times C all over 2 times A. So it's just direct substitution, and then you just simplify accordingly. So 4 times 13 gives us 52. So 36 minus 52 is negative 16. So the square root of negative 16 here, what is the square root of a negative 16? It's a 4i. Remember, the I represents the negative, and then the square root of 16 would be the 4. So we're looking at 6, 4, and 2. Well, they all have a common factor of a what? Of a 2. So when you factor or divide out that 2 and from everyone, this is what you get. You get negative 3 plus or minus 2i, which is what? Negative 3 plus 2i, negative 3 minus 2i. Remember, you can have the plus or minus, or you can separate it. So the quadratic formula, you just identify your A, B, and C, plug it into your formula, and simplify. All right, and remember, the formula will always be given to you for your test, and you'll have it for your test, and then it'll be given to you for your exam. And that is 11-2, and that's it.